P is a point inside square ABCD such that PA is equal to 5, PB is equal to 3, and PC is equal to 7. What is the length of the side of the square? This diagram is at the heart of the question. So first thing I want to do is draw some lines from P to the sides of the square. And those lines are perpendicular to the sides of the square. Now I will label this, I will call A, that distance. This distance I will call B. And this I will call C. And this I will call D. Now therefore, this is also A, that line, and this is also C. Now we know that if we label the side of the square as, say, x, A plus B is equal to x. And very similarly, that side of the square is also x, so therefore C plus D is equal to x. Now we will be able to look at this diagram and create some Pythagorean relationships. And we can do that because those green lines I drew were perpendiculars. They created right angles with the sides of the square. So the Pythagorean relationships are as follows. The first one will involve B and C, this triangle right here. So that means B squared plus C squared is equal to 5 squared. The next one will involve A and C, this triangle right here. So that means that A squared plus C squared is equal to 3 squared. And very similarly, we can create relationships with this triangle. So that would be C squared plus A squared is equal to 3 squared. And finally, this triangle right here. And that will give me A squared plus D squared is equal to 7 squared. Now we will use these equations to get some sort of a relationship between x and hopefully just one variable. So the first two equations, these ones, I will use. And the first thing I'd like to do is subtract them. And if I do, I will get B squared minus A squared is equal to 5 squared minus 3 squared. The C squareds will cancel. And this leaves me with, if I factor, B minus A, B plus A, and that is equal to 25 minus 9, which is 16. Now B plus A we got up there as x. Now B minus A, I'd like to remove as many variables as possible. And I can do that if I do the following. PB, I'll just write over here exactly the same. And if I do that, then what that does is allows me to label this as A. Right here, I'll call that A. And therefore, the distance from there to there will be B minus A. And if you notice, B minus A is essentially equal to the full distance, which is x, minus 2 of those a's. So x minus 2a is equivalent to B minus A. And that is equal to 16. So if we isolate for A, we can do that. X squared minus 2ax is equal to 16. X squared minus 16 is equal to 2ax. And finally, A will be x squared minus 16 all over 2x. Now I will work with these two equations, and in a very similar way, we'll get some relationship between x and hopefully just one variable. So the first thing I'd like to do is subtract them. So that will give me d squared minus c squared is equal to 7 squared minus 3 squared. And factoring, you get d minus c, d plus c is equal to 49 minus 9, which is 40. Now d plus c is x, So that's just going to be x there. But d minus c, in a very similar way, I can get a relationship that will involve less variables. So PB is right here. I will extend PB to go right here. And if I do that, this distance becomes C. And therefore this distance is D minus C. But notice this full distance is x. So x minus 2c is the same as d minus c. So instead of d minus c, I can write x minus 2c. And now I will try to isolate for the variable c. X squared minus 2xc is equal to 40. X squared minus 40 is equal to 2xc. And therefore c is equal to x squared minus 40 over 2x. So I have a in terms of x and I have c in terms of x. And the good news is we have an equation that relates a and c. It's right here. A squared plus c squared is equal to 3 squared. So I will substitute these values that involve x into that equation, and that will allow me to solve for x, which is what the question wants us to do. A squared plus c squared is equal to 3 squared. So x minus 16, x squared minus 16 all squared, plus x squared minus 40 all over 2x all squared is equal to 9. Let's expand this now. We got x to the power of 4 minus 32x squared plus 256 plus x to the power of 4 minus 80x squared plus 1600. And that's going to be all over 4x squared. And that equals 9. Collecting like terms, I get 2x to the power of 4 minus 112x squared plus 1856. Cross multiply this with 9 and you will get 36x squared. Now if I put everything on one side, I get 2x to the power of 4 minus 148x squared plus 1856 is equal to 0. I can divide through by 2, and that just leaves me with x to the power of 4 minus 74x squared plus 928 is equal to 0. Now I have to use a quadratic, or I can factor. I'll just use a quadratic. X squared is going to be equal to minus 74 plus or minus the square root of minus 74 all squared minus 4 times 1 times 928 all over 2 times 1. This becomes 74 plus or minus the square root of 5476 minus 3712 all over 2. This is equal to 74 plus or minus the square root of 1764 all over 2. And this gives me two solutions for x squared. If you take the square root, you will get plus or minus 42. And that leads to the solutions 16 and 58 for x squared. And therefore x is equal to 4 or the root of 58. And since x is representing the side of the square, and we got the solutions 4 and root 58, x obviously cannot be 4, because if it was, this diagram would not make any sense. So the only value of x that makes sense is root 58. And for this question, that would be choice C.